Hey guys, my name is Talia. I'm a staff member at Discovery and I'm going to help you do your homework today. So this question deals with a pregnancy test. And what they want to know is, what's the probability that a person with a negative test is actually pregnant? And so this kind of reminds us of what we've been learning about, which is Bayes' rule. That's conditional probability. So what's the probability of one thing based off of like one condition, given that one condition is true? So we know that Bayes' rule is the probability of A given condition B. And what that equals is the probability of B given A times the probability of A over the probability of B. And we can format this question just like this. We can say, like, what's the probability that someone is pregnant given they had a negative test? And so that can equal the probability of a negative test given they're pregnant times the probability that they're pregnant over the probability of a negative test. But we don't have these offhand right away. So what we have to do is use the statistics that they gave us in the problem and figure out these numbers just like kind of by thinking about it and what it means. So they told us that the probability that the test is correct, no matter like if the person's pregnant or not pregnant, the probability that the test is going to give them the right result is 82%. So we also know by just like subtraction that the probability that the test is wrong is 18%, 0.18. So this can mean that the test is positive if they're not pregnant, or the test is negative if they're pregnant. Those are both wrong. We also know that the probability that anyone who takes the test is pregnant is 0.4, 40%. So the probability that they're not pregnant, this little like 7 looking symbol means not, by the way, is 60%, 0.6. So now that we have these numbers, we can start plugging things in to solve this. So we know that the probability that the test is negative given that they're pregnant, that's wrong, that's 0.18. Times the probability that they're pregnant, that is 0.4, that was given to us in the initial problem. Then, to find out the probability of a negative test is a little more complicated because this could depend on if the person's pregnant or not pregnant. So basically to do this, what you, to find the probability that the test is negative, it's kind of a long expression. You do the probability that the test is negative given they're pregnant, times the probability that they're pregnant. Then you add the probability that it's negative given they're not pregnant, times the probability that they're not pregnant. And the reason why you do this is because when you take this test, there's two different cases. You're either pregnant or not pregnant, right? And then for each of those cases, the test is either going to be negative or positive. And right now, you want to find the probability of all negative tests regardless of status, like regardless of their actual pregnancy status. So you do this with the probability of each status and then the probability of each result for that status. Like you keep this condition in there, you know what I'm saying? It's kind of hard to explain, but all you need to know is that this is how you get the overall negative test probability. And so this ends up being the probability that it's negative given they're pregnant. We already talked about that. 0.18 times 0.4 plus, this is a correct result, so 0.82 times 0.6 for not pregnant. And I did this with the calculator earlier. It was 0.564. Now we can plug this in here and solve this expression to find the original Bayes' rule, and that ends up being 0.12675. I did that math in my head, guys. Isn't that cool? I didn't actually. I just wrote it down over there. Anyway. In Furrier Learn, I think you only need 3 decimals, so you can just round this however you want. But That's the answer.